Hey guys, this is Zach with Berry Right Security. In this video I'm going to be covering how to convert from decimal to binary, from binary to decimal, and then from decimal to hexadecimal. Really, after this video you'll know how to convert from any numbering system if you follow these steps. So this is going to be extremely useful for you to know how to do if you're looking to take the CCNA or Network Plus, Security Plus, you're looking to get a bachelor's in computer science, IT, cybersecurity. It's going to be extremely useful to you. You're going to want to know how to do it. This is what's going to set you apart from the other people that are applying for those jobs. So without further ado, let's get started. So I want to look at like a basic IPv4 address like 192. Oops, sorry. 192.168.200.1. So this is a decimal number. If I wanted to convert it to binary, it can easily be done. This is probably one of the easier conversions. So to do so, you just need to divide the decimal number by the base that you're trying to convert it to. So if I wanted to convert 192 to binary, I just need to convert divided by 2 until there's nothing left. So I'll show you in practice how that's done. 192 divided by 2, that gives us 96, right, with a remainder of 0. Divide that by 2, you get 48 with a remainder of 0. And you just keep doing this until there's nothing left except the remainder. So as you can see, this is easily divisible by 2. You just keep getting a remainder of 0 until the very end. Gives you 3. So you get 2 1s at the end, you get 1 with a remainder of 1. So that's actually going to be your binary address. That's the entire operation. The way you would just write it down would be starting backwards from the 1s here, basically. So the binary address here would be 11000000, which is 192. If you convert it to decimal, and I will show you how to do that right now, the operation behind that, the mechanism. So let's go ahead and clear the screen. And let's start with that the binary number. It was 11000000. So this is 192. We know it's 192. We just need to prove it now. And the way we would do that is through multiplication. So to do that, it's a base 2. So let's start from the right. The first number in something like this is always going to be to the 0 power, and then you work your way up 0, 1, 2, 3, 4, 5, 6, 7, basically. So base 2 to the 0 power, and then you can see there's no coefficient here like here. It's just a 0. So what you want to do is multiply it by 0. And then you want to add. There's an addition operator here, and then you want to add it to the next one to the left, basically, the next 0. So this would be 2 to the 1, and then it'd be times a 0, because it's a 0. So then we're going to add the next one, and we're just going to keep doing that until we've added them all up. So this one's 2 to the 2 times 0, 2 to the 3, 0, 2 to the 4, 0, and we just keep adding them up 2 to the 5, 0. So keep track of this. This is 0, 1, 2, 3, 4, 5. So then we have 6 and 7. So these are different. These are ones. So we need to adjust the coefficient accordingly. So this one is going to be 2 to the 6th times 1 plus 2 to the 7th times 1. So if you add all of this up, what does this equal? It equals 192. How do we know? So what is 2 to the 7? 2 to the 7 is... What is 2 to the 7? It's 128. Put it in your calculator, it's 128. What is 2 to the 6th? 2 to the 6 is 64. Put it in your calculator. Now just add those numbers up, and you get 192. So this will work. This same operation will work for any base, basically. You just have to adjust the base accordingly, like 2, 10, or 16, depending on what base you're in. But for this case, we're in base 2, so we need to use the base of 2 to convert to decimal. So now we're back in decimal. We're at 192. So we want to go to hexadecimal. How do we do that? Well, it's pretty much the same method that we use to go to binary from decimal. So I'll show you what I mean. Okay, we have 192. 192. Sorry, 1 second. 192. So we want to convert it to hexadecimal. How do we do that? Well, we divide it by 16. So what is 192 divided by 16? Well, you're going to have to do a little arithmetic. But according to my calculations, 192 divided by 16 is 12. So we're going to have, it's a clean 12, so there's a remainder of 0. So you would just put a 0 there. And then we have a 12. So we can't divide 12 by 16, so that's our remainder. So how do we write that? If we were to write that like we did the binary, we write it from the end first, so 12 and then 0. Make sure that's logically separate statement, but 12 and 0. So, but we don't write numbers like 12. So that's where the hexadecimal number system comes in, and we have things like A and B and C, D, E, F. They represent these abstract numbers like 12 and things like that. So 12 would actually be A, B, C. 12 is C, right? And then 0 is 0. So if we wanted to write this in hexadecimal, it would be C 0, because C is 12. That is how 12 is represented in hexadecimal, is a C. So that is how you would convert that from decimal to hexadecimal. So if we wanted to convert it from hexadecimal back to decimal, if we wanted to convert CO back to decimal, how would we do that? It's very similar to converting base 2 to decimal, but you have to account for the base 16. So let's do that now. Clear this out. So we have C 0. How do we convert that? So 0 0, 0, but how do we represent that correctly? It's going to be 16, base 16, right? We're in hexadecimal, base 16, and then we're going to be, it's going to be the same as the base 2. So power, think power of 0. Anytime you're starting from the right, your first number is always going to be to the power 0. Base 16 that you're converting to, and then the power 0. And then this coefficient out front is going to be the corresponding decimal number to the hexadecimal number. So 0 is just going to be 0. So, I mean, ultimately 0, you do all that work and you just get 0. So that's nice, but you want to know how to do that, how you logically get to that. And then C, what is C? So we still have base 16, and then it's in the second position, so you're in the power 1. Now what else do? You have to account for this C. So this C is 12. So you want to multiply the 16 to the 1 by 12. And what does that give you? Well, it gives you 192. How do we know that? Well, we know 16 to the 1, anything to the 1 is itself, so that's 16, and then 16 times 12 is, here, let's punch it in a calculator, 16 times 12 is 192. So 16 to the 1 times 12 equals 192. So you can go through and do that for any number, any base, any number. I know this part with the coefficient is a little confusing, but it's not really that confusing. You just have to consider the base that you're in and the coefficient. Like hexadecimal can go higher than 10, etc. Probably the most complicated part about it, but overall not that bad. And if you're able to follow this technique, you will never struggle with networking or CIDR addressing or logical segmenting, subnetting. You will never struggle with those things again. It'll all be crystal clear to you. So I highly recommend getting these fundamentals down for sure, so you can easily convert between any system. And yeah, thank you so much for watching. If you liked the video, please feel free to like and subscribe. If you have any questions, you can message me or leave a comment. I know it's a lot of material to cover in that amount of time, so I went kind of fast. So yeah, I understand there could be some questions, so feel free to let me know. Thank you guys so much for watching, and I'll see you in the next video.